Assalamualaikum warahmatullahi wabarakatuh and have a very good day to everyone. Today we will continue our lesson to subtopic 1.2 resolution of forces for physics form 4. Today we will define the resolution of forces, analyze the resolution of forces of an object which acted by pulling force, and object which acted by more than one force, and lastly, try to do problem solving. So what is resolution of forces? Okay, for example, here we can see a boy and his father. And the father is pulling the boy who sits on a upe leaves with a certain force so that the boy can move. So resolution of forces is the process of resolving a force into two components. So we have a force here. So we need to resolve this force. First of all, we need to resolve the force into the x component, which theta is the angle of force. So the x component of force will be Fx equal to F cos theta. Next, we will resolve the force to the y component at the y-axis and Fy equal to F sin theta. Now let's do a quick exercise here. Find the resolution of forces for question A, B and C. So we have a force with 100 Newton and the angle of force is 30 degree. For question B, the same force with the angle of 45 degree, and question C, 60 degree. So how to do it? Now for question A, we need to resolve the force to its component, which is x component and y component. So x component, as we learned before, Fx is equal to F cos theta. So the force is 100 Newton and the angle is 30 degree. For x, it will be cos. And be sure that the angle is measured from the x-axis. So the answer will be 86.6 Newton. How about the y component of the force? So Fy equal to F sin theta. So F is the force, which is 100 Newton, and the angle theta is 30 degree. So the y component of the force will be 50 Newton. So from here we can see that the component at the x-axis is greater than the component of y-axis, which is smaller. Next, B, can you find the x component and y component for the same force with 45 degree? Find the x component of the force and y component of the force with angle of 60 degree. Now give it a try. This is a slightly different question for the previous one. So we can compare the angle of the force. It is measured from the y-axis, right? So what must you do? Yes, first of all, you need to find the angle from the x-axis. Now I give you time and please find the resolution of forces, which is y and x component. Now one more question, we can see that there is a force with downward direction. Now for the pushing force, there's a question here. Diagram shows a man pushing a lawnmower with a force of 90 Newton. A, resolve the pushing force into its horizontal component and vertical component. For question A, we need to draw the free body diagram. So if you can compare the diagram here, the pushing force direction is to the right and down weight, which is at the x-axis positive and negative y-axis with the angle of 60 degrees. Next, we need to resolve the force into y component and x component. For y component, Fy equal to F sine theta. Remember that the angle is measured from the x-axis, so the angle will be 30 degrees, right? Thus, y component will be F sine theta, which F is 90 Newton sine 30 degrees. So Fy will be negative 45 Newton. And the x-axis, Fx cos theta. Once again, the theta angle is measured from the x-axis, so Fx equal to 77.94 Newton. Okay, we substitute F with 90 Newton and cos theta will become cos 30 degrees. Second question. For question B, state the function of the horizontal component and vertical component of the pushing force when the lawnmower is being pushed. So to answer the first question of B, the function of the horizontal component is to keep the lawnmower forward, and the function of the y component is to push the lawnmower to the ground. Lastly, problem solving for more than one force acted on an object. There's a question here. Diagram shows a wooden block being pulled by force T that inclines at an angle of 30 degrees above the horizontal surface. Table shows the magnitudes of forces acting on the block. Now, for the first question, calculate the magnitude of the horizontal component and vertical component of the pole T. How to find the magnitude of horizontal component and vertical component of the pole T? We need to resolve the force. So the first force I would like to consider is the weight force. So the weight is 24 Newton, but the direction of y component is toward negative y. And how about x component? So for weight, there is no need to resolve the force, okay? Because there is no angle, so there is only y component of weight acted on the object. Can you get it? Never mind, I will explain furthermore. Remember, for coordinate, we have the sign of positive y and negative y. And then we have positive x and negative x. And weight is towards the direction of negative y. That's why y component of W is negative 24 Newton. Let's continue. How about R, which is normal reaction? So normal reaction also same as weight. They do not have x component. So we do not need to resolve 2x component. So R will be 6 Newton and the sign is positive y. Get it? Next, how about T, which is the force that we need to resolve to horizontal and vertical? So horizontal is x component, vertical is y component. So for pole T, for y component, F sine theta, so F force is 36 Newton and the angle is 30 degrees, so the answer will be 80 Newton. For x component, Fx equal to F cos theta, F is 36 Newton, theta is 30 degrees, so the answer will be 31.18 Newton. And how about the frictional force? Frictional force Fr, we do not need to resolve it to its component because it only have direction to the negative x axis. For B, determine the magnitude and direction of the resultant force acting on the block. We have y component and x component for all the forces acted on the block, which is weight, normal reaction, pull, and the frictional force. We need to find the total force acted at the Y component, which is negative 24 Newton plus 6 Newton plus 18 Newton. So the answer will be 0 Newton, and X component is 31.18 Newton minus 20 Newton. So the total force acted at the X component is 11.18 Newton, and its direction is to the right. For the last question, what is the acceleration of the block if its mass is 2.4 kg? Now we need to apply Newton's second law, which F equal to ma. Now the given information is the mass equal to 2.4 kg and the force is 11.18 Newton, right? So acceleration we will force divided by mass. So we'll get 11.18 Newton divided by 2.4 kilo. Now substitute the unit Newton to kilogram meter per second. Thus, we will get the final answer as 4.66 meter per second, which is the unit for acceleration. Thank you, class. I'll see you next time. Thank you. Bye-bye. Assalamualaikum. Keep learning.